Hello, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video is part 9 in a series of videos in which we're going to take the game Boxxle / Sokoban and convert it and make it into GameMaker Studio 2, and then move it over to Visual Studio and put it into a C++ SFML engine. So we're already at part 9, so we've done quite a bit. So what are we doing this time? What are we trying to do overall? We're trying to make a Boxxle game. So again, your guys walking around pushing blocks from here to the goals. Hooray for us. 720p resolution, 60 by 60 tiles. So what are we doing this time? Today is all about textures and sprites and all that sort of stuff. So again, the overall goal is to make an engine and then put a game on top of that engine. Reusable code is our key here. And so today we're going to develop a complete separate singleton texture manager class, and then we're going to take that and basically update everything else to accommodate for that. The object class needs to be played with, and actually we don't have to touch room or game this time around. So we just have to touch, basically object class and a few other little odds and ends. So we'll display the sprite on the screen at the end of the day, and sprite, well, I have a different image for me anyway. And we can finally get rid of that circle object that we've been using ever since we started. So that's where we're going with this. How do I get out of this? There we go. And so now we're going to touch 9 files here in this video. And so here are 2 of them. And let me see, let me move down a little bit. And so here is the code for the Texture Manager class. So if you remember GameMaker, GameMaker has a whole resource section called sprites. And essentially that is the texture section of, or a texture in SFML, where it's a graphic, it's a single graphic. It could be make it broken up into separate tiles, and we'll do that in another video where we actually make a little animation out of the pictures in there. But you can tell it's one picture, and it has all sorts of attributes associated with it, like center positions, remember all that, collision boxes, all sorts of things. And it's their engine, and they did that their way. But we're going to do things using the SFML way, because we're going to take the textures, we're going to create a texture and use stuff that they have already under the hood. So it's going to be a little different, but the end goal is to try to work our way, adapt our way into the middle and work it out. So a texture is what I'm thinking about. This is what a texture manager is. It's basically setting up the sprite section. Where do all of my sprites go so that I can just easily pull them and grab them and do what I need to do with them. So so you're going to see there's a difference. You're going to see nothing but texture here, but then as we move on to other things, you're going to start to see the word sprite. And so remember back to GameMaker as well, that there's a sprite sitting under the hood of an object. And you're like, you can't get out of it. Like either null or give me a sprite that's associated with this object. We're going to obey the same behavior. But then what does that do? That sprite basically latches onto a texture and then does different things, rotates and scales and whatever it needs, and blends, whatever it needs to do. And so why is this separated in this way? The main reason it's separated is just because it's the amount of memory that these graphics would take up. So like for a video game, like what we're making, like if I was having wall objects and I had 600 of them around the bounds of our game, and I created a PNG graphic for every single one of them, how much memory could you imagine that taking up? Tons and tons and tons of memory. But if I just create one image, create that into a texture, and then everybody points and ties into that, I only have to make one copy as opposed to potentially hundreds of copies of things. And that goes for background images and whatnot. These things are megabytes of storage. I don't want to just be taking up megabytes and megabytes and megabytes when I could just use it once and everybody can tie their way in. So that's the theory. So to start with, you can see the texture manager. This is a singleton because there should be one object watching over all the textures in your scene, or in this case, it's going to be the entire game. And you'll see, like I said, it'll all kind of come together. You might have to watch the video. You might already watch it sped up. I would be. And to see what's going on with everything and see how it all ties together. But at the end of the day, once you have it working, you can kind of, if you don't care about all these extra little details, you just can worry on pushing forward and getting the game ready. Okay, so since it's a singleton, the same rules apply. I have a singleton, I have a static instance that's a pointer, initialize the null pointer up here. I have a private constructor that basically does nothing. We'll talk about the map in a second. And then we have a getInstance function that gets me the instance and, basically first check for null pointer and set up a new texture manager. If I need to return the instance, so I have to use the getInstance function basically everywhere I want to use it, but it's globally accessible, which means I don't have to pass it around in a million places. So that's it's a singleton pattern. And now on top of that, now what am I trying to store under the hood here? So I'm going to try to make this a little different than what GameMaker does. Is like if I'm using the texture manager and let's just say there's sprites and textures already in there, and I just can go, hey, get me Pokemon. I know Pokemon's get me Pikachu. Get me Pikachu. Give me the Pikachu sprite. And so like you could send in a string like here, get texture. Like get me the Pikachu sprite. And you would send that string in, and it would return back the texture that you're asking for. Give me Pikachu. It finds that image and gives you a pointer to that image. So that's the end goal. So the map is just a fancy way of holding that information, right? A map is just a fancy set, and a set is a binary tree. So it's, as opposed to a vector that is a contiguous block of memory, this is a tree, which means it's easier to search. And so it's as efficient as it can be to find a string inside of a group of strings. So in this case here, the texture manager is, or the map of this is a string is the key, is the value, key value pair. The string is the key, the texture is the value that comes out of it. So again, if I say give me Pikachu as the string, it'll give me the texture pointer on the back end. So that's what the getTexture function is supposed to do, and it'll return null pointer if things go wrong. I'll discuss it over here in a second. So I have my map, and basically there would be more if we were going to continue on to make this a real engine, but we're just doing the bare bones minimum. So I need to be able to add a texture and then to get the texture, and to get the texture from the map, to get from this data structure. So the addTexture function takes two parameters. It takes a string name, Pikachu, which would be the name of the resource I want to call it, just like think of the resource names in GameMaker, and then the file name. Where can I find the PNG or the actual on the hard drive? Where is this actual image? So, and with those two things, we'll see that we can do everything else we need to do. So everything else there. So let's take a look here again. Null pointer instance, get instance function, texture manager. All this does, the constructor, all this does is just set up the map to be an empty map. And so what does add texture do? It just says, okay, give me a blank, fresh, clean slate texture object. There's no way around that. There's no constructor that handles anything other than just a blank or a copy constructor. And so then you're saying, okay, texture has this function called load from file. And then this is where all the hard work does. I don't know what it does, but it takes whatever file name. As long as it can open up and find it, it will do its job to take the PNG and put it into memory on your, in your RAM so that we can use it as a texture. And then now that I have that texture, like texture object completely initialized, I can take the name of the resource name, and then I can take that and the texture I just created and jam that right into the map. And so that's the idea. And so if things go wrong, you will get an error here. You will get an exception thrown. So like try catch blocks and things like that would have to be. Say like I'm not handling error checking. I'm not handling all those things. I'm just getting the bare bones minimum. Okay, so that's all there is to an add texture, right? That's all there is to it. So the name, give me a resource name, give me a file name, and it jams everything. It does the hard work and jams it in for you. So then get texture. This is the complicated part here, like the find function. So I'm going to pass in get me Pikachu. And so Pikachu, find that in the textures map. And it returns an iterator. You can see it's a map string texture pointer iterator. Holy cow, right? That's a mouthful. And so iter is equal to that. And so if it returns end, textures.end, it didn't find it. Otherwise, it did. And if that's the case, this is a map structure. So hopefully you learned this in advanced C++, or you can look it up and find out. So the key value pair is stored as in a structure called a pair. A pair, is it an object? Yeah, pair, well, a pair structure at the very least. And so the first is the key. I don't know why it's just first and second. The first is the key and the second is the value. So iter arrow second is the pointer to the texture, and that's what's being returned is the texture pointer if it can be found. Otherwise, I'm returning a null pointer. And that's what I'm just using a ternary operator. This is just a fancy if-else statement. If this is true, return this. If this is false, return that. That's all I'm trying to do here. Okay, so at the end of the day, this is the beginnings of our texture manager. This is all we need. Say we're globally able to use this thing, but now how do we use this thing? That's now we've got 7 other files to kind of bring together now. So there we go. So now taking into account the object class. So what now? So you need to say, remember we touched a lot of this last time. So all these 4 functions should be very familiar because that's what we did last time. So now you notice now I added 2 new things over here. A private sprite pointer, and that's a sprite pointer, it's not a texture pointer, and a sprite pointer get sprite function. And just like we have a get window and a get game and or do we have a get game? I don't remember. A get game and a get window game room, those kind of things. We also can get the sprite that this object can have. We'll need this later on, and it's basically the catch-all. Like we can set up little helper functions, but we can't do every single thing that that the sprite object can do. So we still give you access. Like if you know something that we don't give you access to through a helper function, go nuts and have fun with it. Okay, so there we go here. So notice, so my sprite object, notice everything last time was like, let's fill this in later, right? So what are we doing here? So I'm setting, it's a sprite pointer. So because of that, I got to new up the memory in the constructor. And notice now that I've updated the constructor to pass along the resource. And that this is the resource name, not the file name, not where the file is located in memory, but the resource name. This is the Pikachu rather than Pikachu.png. So I'm like, give me Pikachu, because this, or whatever, every object, since every object is going to be derived, will pass up and say which sprite, which texture it needs to pop into this sprite pointer. So that's the goal here. So give me the resource name, and also give me, and I'll also create a brand new blank sprite. Just like the texture, you got to start fresh. And so for like one of the first times ever, we actually go ahead and use this guy here. What I can do here is, let me just I didn't do this before, is put a default parameter in here. So I can say, okay, if I pass in nothing, just consider it an empty string that gets passed in as the resource. And so if the resource is an empty string, well, yeah, there is no sprite associated with this. We do this in GameMaker with the controller objects. We just jam that little question mark. It doesn't have a sprite associated with it, but it does still run code and still looks over objects in our scene and does all kind of stuff like that. So it is perfectly legitimate to want to do that, to have no resource no texture associated with the object. Okay, but all we do then, if you give me Pikachu, I will try and just say, get me the Pikachu, or get texture Pikachu from the texture manager, and it'll return back the texture pointer if it did it right. And so that, again, there are checks and balances in play. Try catch blocks. Say since things are just going to work and we're just getting it done for class, that's fine. But again, real world situation, nope, this is not good enough. So, but anyway, and then set the texture. The sprite has a containment of the texture, and that's the texture object. I guess it's a reference. Is it? Let's see. Is it? Yes, you have to pass a const reference to the texture, and that's what I'm doing by dereferencing the pointer, turning it into a reference so I can pass it along. So now the sprite knows of the texture, and it's using that texture. Okay, so then everything else you've already kind of seen most of this stuff. The destructor, since I've newed this thing up inside of a constructor, when I destruct it, I just delete it, and just for safekeeping, I just set the pointer to null pointer just to kind of clean it up and be nice about it. And so step event, there is more. In future, in a couple of 1 or 2 videos from now, we will fix up the step event, so we can use like speed functions and things like that, so things can move automatically once we set them in motion. But for now, step event is totally useless here to us. But again, it is the default. This is like the only one that hasn't been modified. So the draw, making sure if there is a sprite to draw it. And notice all this gets me to that place, and I just star sprite instead of star circle or whatever, star shape, whatever we had previously. So the if check is needed, right? Because if I get all this way and I go draw and I try to get window and I draw null, well, things are going to crash on me. Anytime you reference a null pointer and try to do something with it, That's why I have this if statement to prevent that crash. And again, the get sprite function very simply takes into account and returns the sprite object sitting underneath the hood here. Okay, so what's cool about this is all you have to do, and we're going to see here, we very rarely have to take over the draw or the step event, or the step event more than the draw, you will see. But all I have to do is set up my object and give it the resource key, and it's just going to start working. So one thing I did is I kind of prefaced that we can finally kill off, and maybe I want to kill it more than anybody else, that circle shape. And since we've discussed SFML object, to get an object, to get the circle shape into the room now and actually have it be part of the room, it has to be a game object. And maybe it was a game object before, but now it's truly a game object. I don't remember anymore. I've been doing this all day. I don't remember. But anyway, here is my circle shape, which now is, no, I guess it can't have been because we're just doing this now. So here is my object. Yeah, whatever. So circle shape is an object, is SFML game object. It takes the constructor, it overrides the step in the draw, and now it has, we've moved things around all over the place, all this stuff. Now it has the shape, instead of inside the room or inside object, now it's moved over into its own sub-object. So here we go, circle shape, shape. And so now its code is just like before. Now I can get rid of these quotes now. I believe I can. Let me just rebuild this to make sure, because I put that default parameter in. All right, happy day. So yes, I don't have to pass anything up if I don't want to, because that means no sprite. And we'll see in an example, my next example, where we do pass in a sprite. Okay, so then pass in and pass up to the parent, nothing, and then initialize the shape like we've done, the circle shape like we've done 1,000 times, 200 pixel radius. Okay, and you've seen this before. The step event for circle shape is the same as the step event like we did before for object. It fills the color for my shape to green, and now I change the color every time just to make sure as I'm working it's working correctly. And my draw now will also draw the shape just like it did before. So just saying, like, once you'll see here that the step and the draw go away in the next class. It's just because we're doing something that doesn't involve the actual sprite, because this is actually drawing a shape, which is not the same as a sprite. That's the only reason why I had to override step and draw. And so I said, well, we're working our way to the end, all these pieces, and then the aha might come if it hasn't already. So here is circle shape. It's all good to go. Nothing to worry about here. So now I created a Samus. I just stole a SNES, I believe, sprite of Samus. And so now this is how I would set up a basic Samus object that just has a sprite that I can draw on the screen. And look, all that went away. I said that the overrides for step and draw are gone. There's no longer anything private because the SFML object holds all that data for me, and I don't even need to pass in anything to the constructor because the constructor will pass Samus, which you haven't seen yet, will pass the instead of Pikachu, I'm passing Samus up into the game object, and that resource will find the texture and pull it in and jam it into the sprite so that Samus will have the correct stuff to go. So this is cool, right? This is, I mean, at the end of the day, once you have this all set up, this is what we're doing. Just like in GameMaker, when we're playing with objects, we're create events and step events and draw events and maybe a few other events. That's what we're dealing with. That's what you're going to be dealing with when you go to finish up and pull in and make the code work. So for Samus, there's just a constructor, but a lot of the objects that will, not all of them, but a lot of the objects we'll be creating for the Boxxle game for real when we get to that level will also take over the step event, because the step event is where all the activity and interaction can occur. Like if the keyboard was pressed, move up, those kind of things. That's what the step event will be for that object. But this is pretty easy. It's just getting used to the flow of this, because for me, I've been doing this for a few years. For you, this is your first time through. So this will be more of the norm. This is just a little, it's somewhere between here and here is what I'm saying, right? This is too far mostly, and this is too close mostly. Okay, so that ties in. So how does this all tie together? And it ties together to finalize everything for now is in that first game initialization room. So this is what you see here. So I have eliminated, if I didn't already eliminate it, I eliminated the other functionality that was inside the .h file for game initialization room, because the room itself, because because it's taking over for room, SFML room, because it's deriving from that, it's already doing the range-based step and the range-based draw for every object in my scene. So I don't need to change that behavior, so I leave it alone. I do not need to play with it. And all I need to do is set up my constructor and just tell it. And so this is, again, this is all for now. We're eventually going to move this. We're never going to instantiate anything inside of the generalization room, the game initialization room. We're going to put that into the true rooms, the main menu, level 1, level 2, all that kind of stuff. So here is what I do to add the texture. And I already put a samus.png file in the same folder in your project where all of these files are. So there's 17, 19 files. I mean, it seems like a ridiculous amount of files already. But there's a samus.png file in there, and I found it, pulled it in. And so what I said here is, okay, this is where I can find the file right at the root, samus.png. I'm going to call it inside the game here. I'm going to call it samus. So where does that come back to? Samus.cpp. So this will get run, right? Because notice how this is run before this is run. And again, the way the things will set up, it will dummy proof later on so you don't forget or do anything like that. It'll be, eventually this will be a do not touch. But again, we're moving target here. So yes, Samus, but this definitely will be changed because you have to say which resource do I want. I want the Samus resource that I created here in the game initialization room. So then now that that texture's been added to the whole overall flow of my game, now I have an instance create function. And so what's cool about that here is, I said all I'm doing is newing up an SFML object, and Samus is, because it's the ISA inheritance relationship, Samus is an object, so I can new it up. A pointer gets returned, and then I go into instance create here. In game, game object. No. Room. I don't have room open, but that's okay. Instance create is part of the room. Let's do it. Room.cpp. Move it over here so you can see it. Where is it? Instance create. The pointer comes in, and it just gets pushed into the object vector. So that now that vector is part of the thing that gets generated every game frame, draws and updates and steps and all of that kind of stuff. And then now the instance create for the same circle shape. And I did this order so that you can see Samus and then you could put the circle on top of it. So I put all of this together, 9 whole files worth of stuff. And what do I get? In my case, this is what I get. So now, because of the order of operations, Samus is first in the vector, it gets drawn first, and then the circle shape gets drawn on top of it. So we can fix that up later on. But this is exactly where I'm looking here. This is exactly what I want to have happen. I have a sprite that comes up on the screen, and then I have this object here on top. So this is a great next step. And so I'll say the next step for this is, so now we have this, let's do a little level generation. Let's get away from the engine. Let's clear our heads a little bit. Let's go back to GameMaker one more time and create a little level editor so we can make our levels inside GameMaker and then port them over and then set some files up so we can load the files and load a level so we don't have to do it all in code because that would take forever and a day. So this time around, I'm not going to do the 9 files and 25 minutes worth of talking. I'm not going to do the recap like I've done for the previous videos, but you see I touched 9 total files here. And if you need any help with that, of course, you can back up and watch the videos again. If you need any help, swardb@cod.edu is always my email address. You can get a hold of me here through YouTube as well. And we're finally getting into the cool, fun stuff when it comes to programming, so I'm looking forward to the next videos. Hope you are too, and see you next time. Thanks.